For our first example, we're going to look at the number of mosquitoes on a tropical island. So our time frame is from 0 to 31 days. The starting amount is 1,000 mosquitoes, so we're starting when t is 0. And this rate right here describes the rate of change of the mosquitoes. So that would be one rate that would include increasing and decreasing. So the amount of mosquitoes, I'm calling M of t. The M stands for mosquitoes. So the amount at any time t would be the starting amount, and that would be when the time is 0. So this amount goes with this time. Plus, you would have to add all the changes. So here's all the changes from 0 to any given time t. And this time t matches up with this t over here. I want you to notice that these are x's here. And the reason why those are x's is because our function here is a function of t. If we put a t here and a dt, then we would end up, instead of this being a function, it would just be, if we plugged our t value in, it would just be a constant number and not a function. So we're changing the t into an x just for this integral. And so that way this will remain a function of x. But what they want us to do here is they want us to find the maximum number of mosquitoes on the island during our 31-day period. So we want to maximize this function here. How do we find the max of something? Well, you need to do the derivative and find out where it's either equal to 0 or where it's undefined. Now, if we did the derivative, these are the two places that our derivative would equal 0 on the 31-day period. From t equals 0 to t equals 31. There is one place where our derivative would be undefined, and that would be when t is equal to 0. But that's an endpoint anyways, so we were going to check that value anyways. Because this is a closed interval from 0 to 31, we're just going to use the closed interval test to find out where we have a max or a min. So the max or min has to happen at one of those two critical numbers, or it has to happen at one of the endpoints, so 0 or 31. Remember, 0 is a critical number and it's an endpoint, so at the end of the day, it's just a number that we got to check what's happening at that spot. So we can see what's happening at our two critical numbers. We're getting a maximum when the time is b, and we're getting a minimum when the time is equal to c. Don't forget, our question wants to know the maximum. What is the maximum number of mosquitoes on the island? So that would be the y value. That would not be the time, but it would be the y value, and they want us to round it to the nearest whole number. So we're just going to say 1039. Now I want to use my graphing calculator, and I want to show you how I'm getting these two times right here. Again, it's just where your derivative is equal to 0. And remember, the derivative was your r function. So that means it's where this r function right here is equal to 0. So I just need to set this equal to 0, and it's supposed to give me these two times right here. I also want to point out that there's a cosine function in here. So that's a periodic function, and a lot of times that will give you an infinite number of solutions. So we just want to look from 0 to 31. We want to see, where does this rate equal 0, or we want to know where that rate is undefined. If we look at our graphing calculator, I usually like typing in the r function on my y1 of x screen. So I'm going to push diamond, and then I'm going to push y equals, which is the f1. Then I'm going to type my equation in right here, and I want to point out that I do have a times in between the square root of t and the cosine of t over 5. And you could use x here if you want, it doesn't matter. I'm using a t here so that it matches up with my function r of t. And then from the home screen, I want to solve, which is f2. The very first choice is solve. And because I wrote my function as a function of t, I'm going to solve for t. So I'm going to push comma t. Then I'll go back inside and put my equation. I want r of t to equal 0. And I typed r of t and y1 of x. So I'm going to put y1 of x even though it's a function of t. So I have that my r of t is equal to 0, and I'm solving it for t. But if I push enter right now, it's going to give me some rule to find the answer. So when you see this rule, when it says at n1, that's just supposed to be an integer. So this is a pretty tricky rule right here. But with the TI-89, we can evaluate it on the interval that we care about. So the evaluate button is right next to the 7. I'm going to evaluate it. If you have your own graphing calculator, you can put this exact interval over here that I'm circling, and it will just give you the answer. But if you have the old operating system, and that's what the online calculator has, you got to say, well, when t is greater than or equal to 0 and when t is less than or equal to 31. So let me type that in right now. You can get the and from the catalog. Push catalog. It's the second choice. Push enter. So it says t is greater than or equal to 0, and I want t to be less than or equal to 31. For the greater than or equal to or the less than or equal to, I'm pushing diamond, and then I'm pushing one of these buttons here at the bottom. I want less than or equal to, so I'm going to push the 0, and I'll put 31. If I push enter, it'll give me multiples of pi. So there you go. This is 7.5 pi. This is 2.5 pi. If I go up, I can scroll over. And you can see it also says when t is equal to 0. Now, t equals 0 is a critical number, but it's also an endpoint, so we were going to use it anyways. But that's how you can get these values right here, the b and also the c. I also want to show you how I'm getting these amounts right here. So I'm going to type this in on the home screen. You can see that I have 1,000 plus the integral. My rate is y1 of x. And I'm saying, well, the t is going to go from 0 to 2.5 pi. And notice I'm writing it as y1 of x, even though it's a function of t. When I write y1 of x here, the calculator is just going to replace it with whatever I had in y1 of x. Now I'm going to push diamond enter. And there you go. I'm getting 1039.36. You can see I'm missing some digits of accuracy. But again, I told you before, you can just go up, push enter, and it will list every single decimal of accuracy that it can. So 1039.3569. We can do the same thing for our C value. I'm going to go up. I'm going to grab the entire piece again so I don't have to type it all in over again. And now I'm going to replace 2.5 pi with 7.5 pi. There we go. I'll push green enter. And I'm getting 842.405. Again, I always like to see that fourth decimal of accuracy, so let me go up, push enter, and now I can see that it's 0.4047. Now I do want to show you how you could type this in your graphing calculator, the entire function, and then you can just plug in all of these values to get all of those answers. Now before we actually type it in, I want to focus on the fact that this has to be an X for your calculator. So that means this has to be an X, and these two letters have to be different. They can't be the same. So we're going to actually change these to T. So these will be changed to X, and those will be changed to T. And that's because whatever you plug in on y1 of x has to get plugged in right here. So for your calculator to work, this has to be an X, and then that is where the number gets plugged in. And we just have to change these two to something other than an X. So I'm going to change those to T. So that's pretty tricky. Let's go take a look. On the graphing calculator, I'm going to go to y equals, so diamond, and then y equals, which is F1. And again, I said my function needs to be a function of t. So this is going to be r of t. So you'll see under y1, I wrote it as a function of t. And then you can see on y2, I replaced the t here with an x. Because when I type in y1 of x, the number that I plug in for x has to get plugged in right here in this position where the t is. So let me show you how I typed it in on y2. You'll notice it says 1,000 plus the integral, but it's y1 of x, and the t goes from 0 to x. So those are the bounds, from 0 to x. But it's a t right here, so this is pretty tricky. So what I want you to do is just try it, plug it in the way I did, and then go to the home screen and see if it works properly. So remember, that was on y2. So I'm going to do y2 of, and I'll try 0. You can see it's giving me the 1,000. So far, so good. When I plug in 2.5 pi, here's what I get. All right, that looks good. It's matching up. Let's try 7.5 pi. There we go. There we go. We're getting 842.405. Looks like it's matching up. And let's try 31. There we go. We're getting 964.335. So everything's looking right. So again, take out your calculator, see if you can type it in and see if you can get it to work. Okay, one word of caution about your graphing calculator. You got to be really careful. If you ever type a function equal to an integral, Do not try to graph that. It will be a total disaster because the way that your calculator works is it plots a bunch of points and then it connects the dots. But just one of these points with your graphing calculator can take anywhere from 10 to 20 seconds. So what will happen is it will lock up your graphing calculator for a very long time, probably like 3 hours or so. And even if you have your own graphing calculator, you cannot take out the batteries. It won't do anything. It won't stop it because your calculator has its own backup battery. We did figure out that if you push the on button, it will stop it. But even the online calculator, that doesn't work. So let me just show you. If I do diamond and then I push graph, you're going to get this little busy thing and it will be there for many hours. You won't be able to use this calculator anymore. And even the online one, you better get a new tab and you better start over with a brand new calculator. Because even with this online one, pushing on doesn't do anything. It doesn't stop it. If you have your own real calculator, that will stop it though. That will stop the graph from trying to continue. Because right now, this calculator is going to be useless until it finishes graphing this. And that'll probably take a couple hours. So just a word of caution. Do not push graph if you ever have y equals and then an integral. Again, on our calculator, we're plugging in x here. This should be the x. So that's going to end up being x. We're just switching the letters. And then this has to be a function of t. So it's r of t. And then the dt part is because the t is going from and then 0 to the x. So that's pretty tricky there. You really just got to get out the calculator, punch everything in, and see if you can get it to work. Now I do want to tell you that you don't have to type this one in your graphing calculator. And that's because it tells you that when t is 0, you already have 1,000 mosquitoes. So it kind of tells you that when the time is 0, you have 1,000. So don't waste your time plugging that in the graphing calculator. I always want to end by making sure that we answer the question. It says, what is the maximum amount of mosquitoes? So we got 1039. And remember, it says round to the nearest whole number. So that's why we do not include the 0.356. It does say to show the analysis that leads to your answer. So you can't just put the correct final answer. They want to see your work. All right, we spent a lot of time showing you calculator stuff. So we're going to go through these a little bit faster. We're not going to keep showing calculator stuff. So we're just going to pay attention to the concept on these ones. For this example, we have a rate that the sand is being added. And then we do minus. And then we have a rate that the sand is being removed. And so together that's our rate. So we're calling it A prime, where A is just the amount. So the amount at any time would be the starting amount plus all the changes. So if you look at the rate inside here, you have the add rate and then minus and then the remove rate. You'll notice that this time goes with this amount and that this t is the same as this value here. First question says, at what time is the amount of sand on the beach a minimum? So we want to minimize this function. So how do you find the min of a function? You do the derivative and you find the critical numbers. And so that would be where your derivative is either 0 or undefined. This derivative is equal to 0 at this value right here. That's a time. So when t is equal to 5.1178. And because this is a closed interval, we got to check the critical number, but we also need to check the endpoint. So we need to check 0 and 6. So we plug it into the amount function. In the previous example, we saw how you could plug that in a graphing calculator. And so we can find the amount when you're at 0. That was given, it's 2,500. We could find at our critical value, the amount would be 2492. And then at our ending time of 6, we get 2493. Again, we are looking for the time when there's a minimum. So the answer would be the time for that first part. So this would be the answer. The units for that would be hours. So it'd be 5.117 hours. And then part B says, what is that minimum value? So the answer for part B would be this number right here, 2492.369. And that's pretty much it. We're going to look at our last two examples, and our last two examples are where you want to maximize or minimize the rate. So these are different because you're not maximizing or minimizing the amount. So we've seen this example before. We have some rate. This function is the rate that people enter the auditorium. The units would be people per hour. So for this example, it says find the time, so our answer will be a time, when the rate that people enter the auditorium is a maximum. So we want the maximum of this function here. So how do I maximize r? Well, I need to do the derivative of r and find out where it's either 0 or undefined. That happens at these two spots. So those are going to be kind of like my critical numbers. So this critical number is in between our two endpoints. Our endpoints are 0 and 2. You'll notice that 0 was actually one of our endpoints. So we can kind of ignore that one as a critical number because we were going to check that endpoint anyways. So we kind of really just have one critical number that we're going to check, and then we have our two endpoints that we're going to check. And basically, you just plug them into the original function, so we plug them into our rate function, because that's the thing we're trying to maximize or minimize. In this case, we want to maximize it. So you plug in your critical number into that rate, you get 854.527, and we check the endpoints. The endpoints give us 0 and then 120. So the maximum clearly occurs at this time. So we'll say when your time is 1.362 hours. And that maximum amount would be this amount here. And don't forget to answer the question. The question wants to know the time, so your answer is just this time here. And again, the units were hours. So there's our final answer to our question. And here's our last example. Again, they're giving us a rate called f of t, and that's the rate that the distance between the shore and the road is changing at any time t. Units would be meters per hour. So the question is again asking about what time, so our answer is going to be a time, during the 5 hours of the storm, was the distance between the road and the edge of the water decreasing the most. Now the distance between the road and the edge of the water is kind of like your d, it's your distance function. You could say d of t. We don't actually know that function, we haven't written it down. If we wanted to write it down, it would look something like this. Here's your distance function right here. Just be the starting amount plus all the changes. And the starting amount was 35. To get the changes, just the integral of the rate. So if it just wanted to know when that function was decreasing, we could just see, okay, when is the rate negative? But it wants to know when is it decreasing the most. So what we have to do is we got to find the max or the min of this thing here. And that will tell us the most. So how do you find the max or min of f? Well, you got to do the derivative of f and see where it's either 0 or undefined. These are the two spots where your derivative would be 0, and this is where your first derivative is undefined. That turns out to be an endpoint anyways, so we don't need to write that down. So we got to test this value at the two critical numbers and at the endpoints. That's how you do the closed interval tests. Just see how big they are and how small they are. The biggest one is the max, the smallest one is the minimum. You'll notice that the derivative is negative for all of them. And so what that means is the original d was decreasing for all of these values here. Well, we're looking for decreasing the most. So you can see at this time, the distance is decreasing the most. It's decreasing by 2.269 meters per hour at that moment in time. So our final answer for this one is going to be C. When I say C, I mean it's a time, 2.840 hours. And that's it. That's our last example.